In this video, I wanted to do another example of a chi-square test. We did one in live class the other day where we looked at basically the living situation of college students and the change between, the statistics of how many live with their parents versus how many had their own place as they got older. And we calculated the chi-square statistic with a calculator. And we looked at how you would do it if you had to do it by hand, but we didn't do the whole thing because it would be quite tedious. But got through those basics and then talked about how to interpret the results of the chi-square statistic from there. So let's just look at another example. I found an example online just by searching for a chi-square answer, just to look at another example of this. But in this case, we're looking at basically the statistics of education and basically who was never married versus married, divorced, or widowed, just to sort of see, is there a significant difference in those sorts of statistics? And again, we can look at this with a calculator. So again, it would start by knowing how many, your total sample kind of broken down into various groups in the form of what we call a two-way table. Again, for our degree of freedom, it's always the product of the rows minus 1 times the columns minus 1. So we have 4 by 5. So we do 3 times 4, which is 12. So, right off the bat, we could know our degree of freedom is 12. So if we're using the chi-square table, we'd want to be using this row down here to find our p-values. And then, of course, we always need to find the expected counts first. So, to find an expected count, we just need to take each of the totals. So say we wanted to know, well, again, we're assuming the null hypothesis is that there is no difference between any of these groups. They're all homogeneous, which usually that's not the case with real data. And so the alternative hypothesis is that there are some differences, and that's kind of what we're looking for, statistical evidence of that. And so what we want to do is figure out our chi-square statistic, but we need our expected counts first. And the expected counts are always based on the assumption that everything is the same. And, the expected count for how many we would have never married in middle school or lower should be this times this divided by this. So the row column, or the column total times the row total divided by the total. So 39 times 90 over 300. This would give us an expected count of 11.7. So what we can see is that the actual value of those who only have a middle school education or lower, being never married, is a little higher than would be your average, assuming they're all the same. We can do the same for high school. We do 90 times 90 divided by 300. And this would give us 27. This one's a little higher as well. And again, if you took that and subtracted it from the actual and squared it, divided by the observed count, we could calculate our chi-square statistics for each of these. So, if we did 18 minus 11.7, then we were to square that and divide it by the expected count, we get our chi-square statistic for the first entry. And again, since we have a total of 20 entries, we have to do that 20 times, add up all the results to do the total chi-square statistic in this particular case. Or again, we could have a calculator do it for us. And also on this particular link, they've shown us the percentages. It does appear as though there is some change in these proportions based on higher education level. Those with higher degrees are way more frequently married than those that are not. And again, if we had the chart for the expected values, we can see that down here, and we could use that to calculate our values. But if we're going to do it with a calculator, we need to enter all those into our matrix A and matrix B menu. So in the matrix menu, we can edit this. This data is 4 rows by 5 columns, so we need to do 4 by 5. We'll start with A as our actual data. So we have 18, 36, 21. Got all those in. Then we'll go back to matrix, edit matrix B for our expected counts. Again, we would normally have to calculate that, but the reason I bring up this page is they've already done it for us. That's most of the work that we're going to need if we're going to use a calculator to do this. And again, that's pretty simple to do, very easy to do in Excel. Perhaps I'll show you guys how to do that at the end of the video. So it looks like I missed one already. Let me go back and double check. Okay, that one's good. $27.16.5. The divorce expected values, again, assuming everybody's homogeneous. And divorce and widow are both the same because they had the same total. Okay, now that we have all that in, we can go back to the main menu, and we need to go to our chi-square test. So if you go in second stat, scroll to tests, you can find your chi-square test somewhere in here, the letter C. And then again, observed, just type in which matrices you have your data stored into, and we can hit calculate. So if we hit calculate, we will come up with our total chi-square statistic, which you could have calculated by following through the process which I said before, along with our expected p-value. So here we're getting a chi-square statistic of about 23.5. And again, if we did not use a calculator, you could use table D to find your p-value, because again, as I said, we're in our degree of freedom is 12. So if we see our, if we find a chi-square statistic of 23.5, it would be somewhere between here and here. So we would know that our p-value should be somewhere between 0.025 and 0.02. It gives us a pretty tight range of what our p-value would be. And as we see in the calculator, it's somewhere in the middle, about 0.023. So if our alpha significance level was 0.05, we would confirm these results and say there is significant evidence that there is a difference between these particular groups. However, if we're trying to go on a significance level of alpha equal 0.01, it would not be significant enough evidence to go through it from there. And this article gets into a little bit more about how you could do these things a little bit more with Excel, calculate these things a little bit more, and so forth. But it gets into great detail if you are curious, but that is enough for the purposes of our course.